Here at Ada, which is a spin-off of Proximus. It's only like 1 month that it's existing, this Ada. And he's going to talk about network analytics. So if you have a problem with your network, I will give you the private number from Andeas, and he will fix it. Without yellow jacket. He likes IPA beer, which is also none of my favorites. And actually, I'm going to expect a lot of this talk because he's already been preparing it for 2 years. He was going to suppose to talk about it in our event on March 2020. Unfortunately, we had to cancel that, and we're very happy that he's here tonight. Go ahead.
So please don't contact me for your Wi-Fi issues. Literally every family reunion I have to face these type of questions. So please don't. So I would like to talk about network analytics today. So my name is Andeas. I'm a machine learning engineer at Proximus. So I won't be focusing on the many other interesting stuff that we do at Proximus Ada or Proximus. So we have over 85 advanced analytics use cases in a wide range of domains. So I won't only be talking about this part, but I just thought it would be interesting to put it on a slide to get a grasp of what are the really cool stuff that we're working on. So purely focusing on network and next best action. So we also have initiatives on our future network. So you might know that we're migrating our copper network to fiber, for example, where you have a ton of interesting stuff to, for example, outphase copper networks and stuff. You have a ton of initiatives on predictive maintenance, so trying to predict if a customer would call, if a street cabinet would fail, everything linked to anomaly detection and such. But I think it would be interesting if I just focus on this one. So next best action. So it's actually a range of initiatives that we launched with the following mission statement, and that is to basically provide the next best action at any point in a customer journey. So the basic goal is really, imagine that a modem has an issue, imagine that a street cabinet is an issue, just a customer or a decoder. You can imagine there's a ton of stuff happening on our network. For each of these elements, we'd like to be able to say at any point in time what will probably be the next best action, that is, the solution to your issues. So to make it a bit less abstract, I will come with one concrete use case, which is the following one. Imagine that the customer calls for a technical problem. So he literally picks up the phone, it's a 0800 number, I don't exactly know it by heart. But anyway, he calls the call center. Actually, there's already a ton of models, machine learning models, that try to predict what type of solution will be required for his or her technical issues. Very specifically, in this case, so we have, like I said, other initiatives, but in this case, what we try to do is try to predict the outcome of a field intervention. You might not know it, because for non-Proximus people, it's all the same, but there's actually a ton of types of solutions that you can identify for fixing these issues. There's a technician, that's the guy who comes into your house, swaps the modem, for example. There's a splicer, that those guys in the vans out in the street that you see that literally splice cables. So they need to open up the ground, they need to dig a hole, and then even when it's very rainy, they are literally splicing cables. There's also the possibility to do a modem swap via repost. You can imagine if you can just predict that a remote modem swap is possible. So it's literally us sending a repost modem swap through mail. It's a lot less expensive, and also for the customer it's nice because you can just take it out of your mailbox and install it yourself. And so you can imagine that if you are able to predict these types of solutions, in this case it's only 3, but we actually have more, it's actually very, very interesting for us as a company. And so that's exactly what we did. So this model and the iterations of it have been running in production since 2017, and actually we're really, really successful in doing so. So we see that if we make a prediction, in more than 90% of cases, we're actually correctly predicting the type of intervention that we need. So we use a ton of data to do this. There's modem data that's produced, there's information about the topology, about the length of your cable, about the type of technology that you're using. In total, I think the current iteration works on around 1,700 features, give or take. And so that's an interesting one, and it gives you a kind of a grasp of what is actually one of our key projects, I guess. And so I want to talk a bit about what makes this complex, because it's always interesting to open up the hood of the car, I guess. And so this is all classified under the umbrella of network analytics. Here you see like a very short visualization of our actual network. So these are end customers, how they propagate through the network up until a street cabinet even. So you can imagine there's way more than just this network. And so first of all, it's a complex network topology. Secondly, is the many data sources. Each of these nodes produce data, if it's a cable, if it's a street cabinet, whatnot, and somehow you need to find a way to propagate this data nicely to one entity and then to your machine learning model. Data quality of actions as well, so you have a lot of information on technicians claiming that they did stuff like swap the modem and whatnot, but that's not always very qualitative to work with. And also there's a lot of actions possible for the same root cause. We see that for the same kind of person, if we swap the modem or if we decode it, actually it leads to a final solution. So that means that the customer doesn't call back in either of those cases, which makes you wonder how people decide if the machine can't even decide in their cases. And there's a lot of customer-specific content as well. So there's a ton of vendors you can imagine in the telco space, but none of them have the same combination of vendors as we do in terms of technology, in terms of hardware and software, etc. Voilà. And so what I felt was also interesting is to share what kind of enablers that we used to do this, because I think those three components are very, very key in order to achieve these kind of initiatives. It's first of all a central API, so we call it an NDA API, Next Best Action API, for the entire company to consume, basically. I will go into that in a second. A central repository for all technical repair actions. So that means you have a 360-degree view on everything that we do on our network, whether it's this type of technician or another type of technician. You can imagine that there's ticketing systems all over the place. And the last but not least, our central feature store. For those of you not familiar with the feature store, I will explain in a second as well. So the first one is the one-stop shop to our API. And what we developed is basically something which anyone in Proximus can go to. So if it's a technician, if it's a guy in a suit, if it's a residential customer, if it's a call center agent, anyone can go to our API and say, look, I have this issue with this one serial number of this one customer. Please tell me what I should do to resolve these issues. And so that's all centralized in our one-stop shop, basically. Secondly, it was a central action repository. So that means that we basically combine all types of actions into one overview. And the view that you see here is just one view that displays the modem swaps, for example. That was one case we saw before. And then displays a ton of other metrics around. So you see that actually more than 50% of all modem swaps are now triggered by our AI at the moment. And so you can imagine that our never-ending goal is to increase this percentage as well as the precision and the recall in this case. So you also see like average task time, the customer experience and such. So it's also quite challenging in the sense that you need to optimize for many metrics. You can imagine that it's not only cost or profit that you want to maximize, probably the commercial company in the end you want to do, but also customer experience and such, which are also metrics that you can measure. And then last but not least, I talked about our feature store. So we gave the name Thesis. It's actually called after the Greek mythology of the guy who needs to run through the labyrinth. And the reason behind it is that we had a lot of issues identifying data throughout the company. So we kind of felt like Thesis finding Ariadne. And so this is, I would say this is really the engine of everything we do, because it allows data scientists to very easily exchange features for whatever model they want to build. So imagine that your colleague builds a nice feature set on top of modem data, let's say. You don't really want to care about the knowledge that you already gained. You just want to plug in your own model, or at least plug the data into your own model, and just use it. So that's exactly what we intend to do here, to make it very, very easy to reuse features. And I really think that this is something which, is a very big importance of our model. So what we intend to do is to have some kind of delivery engine to constantly improve, to add new actions, to increase our data sources, and to improve our algorithms as we go. And last but not least, if you want to help us tackle these types of changes or challenges, do come and join us. We have a ton of open vacancies out there, be it in AI or cybersecurity. I'm very happy to talk about it in the next phase. Voilà. Any questions?